Alright, so the first derivative, that's what we're going to talk about today. So you use the first derivative to find basically the maximum and minimums. What you're going to do is a summary, is find the critical values and endpoints and see what happens at these points. So a relative or local maximum minimum, depending what kind of term you want to use, is a curve that has a horizontal tangent line at that point, but it's not the highest or lowest value. I'll show you an example of that in a little bit. An absolute maximum or minimum may occur either at the point of the graph or at the endpoint. So, an example, this is an endpoint, that's the absolute minimum, or it could be just a point on the graph, and that's the absolute maximum. So a maximum, this is an example of a maximum. As you can see, it is the highest point around here. The tangent line here is 0. Now this is a minimum. The tangent line here is 0, and it's this curve right here. Okay. Now, this graph is a clear example of where absolute maximum and absolute minimum are, and local mins. So this is a local max, local min, local max, local min, absolute max because it's the highest point on this graph, a local min, a local max, a local min, a local max, and an absolute min because this is the smallest point, the lowest point, sorry. And as you can see, I drew dotted lines to show that at these points the tangent line equals 0. Okay, so when you're doing derivatives, you want to be able to do them both mathematically and just looking at a graph. So I've showed you some graphs of how you can analyze it. Now I will do it mathematically. So this is just a very basic function. So this is f of x equals x squared plus 2x plus 1. So what you want to do for the first derivative is take the derivative of this, which is f prime x equals 2x plus 2. So now you're going to set this to 0. Sorry, just skip this step. Okay, so this is your critical point right here. I skipped a couple of steps ahead. So when you have a number that's less than -1, for this example I use -2. In the prime function you get -2. So this is decreasing. And so I'm also going to use a number that's greater than -1, and I use 0. And when it's plugged in, you get 2, which means it's increasing. So now your next question is, so what does this mean? So now that we have our math done, we can come over here. Let me make a quick graph. And -1 is right here. When a function's decreasing, the derivative, it's doing something like this. Comes to -1, and as we see over here, at -1 to infinity, it's decreasing. So we do that. So the function looks something along these lines as a parabolic figure. So this is the first derivative, and at -1, like we saw in our original example, at -1 it is 0, so this is the first derivative test. Okay, so after this example, there's more intricate problems, like with using this tool. So these are just some examples that you may come upon with your calculus. So whenever to the left of the point it's greater than 0, and to the right it's less than 0, we'll have a max. If you have a point that from the left that's less than 0 and to the right is greater than 0, you'll have a local min. And then once it starts getting a little more complicated, you'll have problems where, right as you can see here, there's the tangent line can't be 0, So there, it does not exist. It's neither a max or a min. And over, as you can see, it's both to the right and to the left. It's both greater than 0. And over here, vice versa, they're both less than 0. So, and then you can get graphs that look like this, where it might not exist, but it is a local min, and that could be if to the left it's less than 0 and to the right it's greater than 0. So this is the first derivative. Thank you. I just wanted to tell you one last thing before I go. You always have a critical value at when there's a change in sign. So this is just a purely example for the first derivative test. So you have your tool here. Let's just say our a point that we found when the first derivative is equal to 0. The point is 0, and whatever the function was, you put a number that's less than 0, and let's just say for the sake of this problem that it's increasing, and to the right of it it's decreasing. So you know that because there's a change in signs there, that this is a critical value point.